Hi, sixth graders. We're on lesson 4.1. So if you could start a new section in your notes notebook, label it lesson 4.1, and you can write prime factorization on the top. Our learning target is being able to express a whole number as a product of prime factors. So as you recall, and probably have learned previously, prime numbers are numbers that have two factors, itself and 1. So only two factors. So 2 is actually the only even number because all even numbers are able to be divided by 2. But 2 is only able to be divided by 2 and 1. 5, 7, 13, 29, and so on. So all prime numbers can only be divided by itself and 1 to get a whole number. Obviously, all numbers can be divided by anything you want, but to get a whole number, it's only itself and 1. Composite numbers have more than two factors. They can be divided by more than itself and 1 to get a whole number. So we know that 4 can be divided by 1 and 2 and 4. 100 can be divided by 1 and 2 and 4 and 5 and 10 and 50. So 100 has a lot of factors. Some numbers have more factors than others, but it's important to be able to pick out if a number is prime. So make sure in your notebook you have prime numbers and composite numbers so you know the difference, and maybe a couple examples of each. So when we talk about prime factorization, and if we think back to what that learning target was, it's being able to write a whole number as a product of prime numbers. So prime factorization is taking a composite number and figuring out what prime numbers can be multiplied together to get that number. So there's two different ways that you can do prime factorization. And you probably want to at least write down one of my examples, maybe a couple, until they make sense to you. So our first method of prime factorization is using a factor tree. So what we do is we would, if we're going to take the prime factorization of 12, we would figure out two numbers that when you multiply them together, you get 12. So I'm going to do 6 and 2. You could do 3 and 4, obviously, but I'm going to do 6 and 2. And now I ask myself, are either of these numbers prime? Well, 2 is prime, so I'm going to circle it, and then I'm going to be done. But I know that 6 is not prime, so now I have to go down a little bit further and do another tree. And I know that 2 times 3 is 6, and then I know that 2 is prime, and 3 is prime. So my prime factorization of 12, and then we want to write these numbers in order from least to greatest, is 2 times 2 times 3. Or we can say 2 squared times 3. And then I know that 2 times 2 is 4 times 3 is 12, so then that works. We always want to make sure that our prime factorization, when we multiply it out, it actually does equal that number that we were trying to find the prime factorization for. If we did division of primes, what we do is we start with 12. And this time we're going to think of, we're always going to have a prime number that we divide it by. So I know that 12 can be divided by 2, which is prime, and 12 divided by 2 equals 6. So then I know that 6 can be divided by 2, which is prime, and that equals 3. And this should be a nice straight box. And then I know that 3 can be divided by 3, which is prime, and that equals 1. And we go all the way down until we get to 1. And then these numbers on the outside are my prime factorization. So then I have 2 times 2 times 3. And I get the same exact thing, 2 squared times 3. And 2 times 2 is 4, times 3 is 12. And if I would have started with 12 and divided by 3, and put a 3 out here, and then I get 4, then I would divide it by 2. If I go in a different order, or I divide different numbers, I still would get the same numbers. So it doesn't really matter which way we go. Okay, we're going to do 30. And I'm going to do another example for you, and then the next page is going to be for you to try on your own. So 30, using factor trees, I know that 5 and 6 equals 30. Remember, these two numbers have to be multiplied to get 30. So 5 times 6 is 30. I know that 5 is prime, so I'm going to circle it and I'm going to leave it. 6 is not prime, so then I do 2 and 3. I circle my 2 because it's prime, and I circle my 3 because it's prime, and then I'm done. So I keep going. Like if this wasn't prime, then I would keep going until I get all prime numbers, or all circles on the bottom. And then my prime factorization is 2 times 3 times 5. All prime numbers, 2 times 3 is 6 times 5 is 30. That's another thing that you always need to check to make sure is that these numbers are all prime. And then if we do division of primes, 30. So I know that 30 divided by 10 is 3, but 10 is not prime, so I wouldn't put 10 out here, but I could put 3 out here because that's prime, and then I could put 10 down here. And then I know that 10 divided by 2 is 5, because 2 is prime, and then 5 divided by 5 is 1, and then we're done. So then my prime factorization is 2 times 3 times 5. Okay, I want you to pause me and do 200 with a factor tree and division of primes, and then come back and check your answer. So 200, I know that I'm going to do 20 times 10, and then 20, I can do 4 times 5, and 10, I can do 2 times 5. And I see that 5 is prime, 2 is prime, and 5 is prime. 4 is not, so I'm going to keep going. 2 and 2. And then I circle 2 and 2 because those are both prime. So now I have 2, and I have 3 2's. So here we'll write it out. 2 times 2 times 5 times 5 is the same as 2 cubed times 5 squared. And then if I do the division of primes with 200, then I can take 200 and I know that 2, I know it can be divided by 2, and I know that 2 is prime. So again, it doesn't matter what number you start with, but 200 divided by 2 is 100. Oops, my mouse is not letting me make straight lines. 100 divided by 2 is 50. There, that's a little better. 50 divided by 2 is 25. 25 cannot be divided by 2 to get a whole number, but I know it can be divided by 5. And then I get 5. And then we know it can be divided by 5. And we get 1, and then we're done. And then we have the same thing. 2 cubed, because I have 3 2's, times 5 squared. So you should have gotten both of those for your answers. Now you can decide which method you like better, or if you want to keep using both to make sure you understand both. But if there's one that you prefer, then you can definitely just do one of them. But I always like to show both methods. And then if we have a variable involved, it's very similar. 24xy is the same as 24 times x times y, and 24 we can factor out to 4 and 6, and then 4 is 2 and 2, 6 is 2 and 3, and then I circle them because they're both prime, or they're all prime, I mean. So then my prime factorization is 2 times 2 times 2 times 3 times x times y. So we would write 2 cubed times 3 times x times y, and see how important it is to be using that dot for multiplication instead of x. And then we would basically do the same thing for 4abc. I know that 4, the prime factorization is 2 and 2, so then I would do 2 squared times a times b times c. So if there's variables involved, we just split them up so we know that each one is being multiplied by and it's being pulled out on its own, but we don't need to actually factor it out. Okay, remember you can go back and re-watch the video if you would like for better understanding, and remember to log into NICU and take the 4-1 NICU quiz. Have a good evening.